Okay. Uh, Last 2014 MOM, what I presented was how to bind many modems to achieve a higher throughput. If you can still remember the 2014, I binded 30 DSL modems to achieve like 300 megabits of bandwidth capacity. Now this time, at the time, fiber wasn't available that much in those areas. This time, it's a different thing. Instead, we have I have a 100 megabits fiber that which we need to I need to distribute on three different places. Now I have a case study here. Let us. The case study is about a main site with the only access to a fiber service, multiple sites with different distances from the main site. So if you look at the diagram, site 1 with less than 1 kilometer, site 2 with 2.5 kilometer, and site 3 with 4 kilometer. The client's requirement is to distribute the bandwidth equally and dynamically, meaning each site should get a specific bandwidth. Then single point of operation like an NOC, and then an independent bandwidth management for each site without affecting other sites. Before I go on with the presentation, we will look at the most typical solutions that I have seen and the problems associated with it. Now, this is a typical point to multipoint solution. I've seen this kind of deployment for many times done by my client, sometimes done by their contractors. And this kind of connection is very unreliable. If you do understand the wireless system, you would know that a point to multipoint is not always a good solution. First, it is prone to frequent disconnection due to interference, slow wireless speed, if one of the site is transmitting or receiving continuously at the same time. Now let's look at the design and see how we can how the disadvantage and advantages of this configuration. There's a lot of disadvantages with this kind of design from point to multipoint. One, slow wireless internet speed due to multiple access on a single channel. So if you have like 54 Mbps wireless speed, theoretically you should be able to achieve 54 in one direction if only one site is transmitting. But if you are transmitting both at the same time, each side is transmitting and receiving at 27 Mbps, and that is only for one site to one client. I mean, one AP to one client. If you add another client to that, it will be divided further and further. With point to multipoint, I don't really recommend it for deployment for the branches, remote sites. It's only good for hotspot or free Wi-Fi, things like that. I don't recommend this kind of setup due to if you are in a mission critical or high bandwidth requirements for the end user. So that is one of the typical solution, and I have seen something like this connected to a router board and then a fiber link. Again, this is a very typical setup that most people would do. Connect every site to a single access point, and it creates a bottleneck in the wireless link. Then followed by a simple queue. If you will look at the MikroTik wiki website, it will suggest how to use a simple queue. Basically, simple queue is based on IP address limiting rather than on a per interface. Simple queue is linear as it goes through all the IP lists or the IP addresses until it gets the matching list, the matching hits. The problem with the simple queue is if you have so many queues on your list, it goes through each line. So if you move queue number 10 to number 1, that will be processed first. So if you have lots and lots of queue lists with a simple queue, it will cause a lot of latency. And that is not a solution for a what do they call this? Mission critical applications. Okay? Then most of the time, I see CPE with the Mangle rule in it. So you don't have the full control of each site. Instead of controlling it with your RB core router, you got to control it on every CPE. Another thing is that if you'll notice, the whole network must be on the same subnet. Site 1, Site 2, and Site 3, and then you have the core router. It must be on the same subnet, and that could cause broadcast storms. That could cause a lot of troubles because you need to manage a large number of IP addresses. Now, a better solution is to point to multipoint. Let's go back first. With the point to multipoint, one of the problem is you must use same coding scheme. In other words, 3 different sites must use what is set on the access point. In other words, if you use an 802.11, then you must 802.11n, then all sites must use the same thing. Now, a better solution is to use a point to point. The disadvantage of point to point is it is cost prohibitive. It's very expensive to deploy, but it gives you a better, more reliable connections and speed. It's not on a shared wireless speed. You can have one point operating on a different frequency and a different modulation coding scheme. It is less prone to interference and with a higher throughput. And of course, long distance links. Then attach it to your CCR, and each point can be attached to a separate or isolated port. So what happened here is you have 3 different sites with its own physical interface port on your CCR. So there is an isolation. Now, with the Q3, what I like the most with the Q3 is that you can actually control the bandwidth based on the interface, not based on the IP addresses. All right. Another thing with the Q3 is it processes in parallel. In other words, all queues can be processed all at once. Not unlike with a simple queue, it must go through all the list from the top to bottom. So that does creates the delays and latency, while a Q3, it can process the packets and the queues all at the same time. Next, all Mangle rules, bandwidth management for each line is controlled at the core router, and that is what we want because what we need is a single point of operation, the NOC. Each remote sites do not have any configuration at all. They're just set as a bridge. nothing at all. Every control is on your core router. Then uh, firewall rule is a lot more easier because you're not only dealing with the IP, you can create your firewall rule on a per interface basis rather than IP addresses. Now here is the general design that I have done to a client. Remote site 1, 2, and 3 with a different radio. The remote site number 1, the distance is less than a kilometer, and I used SXT HG5 AC model. Remote site number 2, the distance is about 2.5 kilometer, and I used QRT5 AC on that site. The same with the remote site number 3. Now all radios are configured as a bridge mode only. No bandwidth or firewall rules or management on radios. All radios and remote sites are controlled at the core router, higher throughput on each segment. The good thing about the point-to-point system is that you can actually get the theoretical speed. If the advertised speed is like 850 or 500 megabits, you can actually get it because it's only two sites using the channel. Not unlike with the point-to-multipoint, you have to share it, so it gives you unreliable speed. If one of the site continuously transmit and receive data on the point-to-multipoint, expect the rest of the site will be having trouble with the wireless speed. Now, there's not much of I'm not going into a deep configuration details, but I will only cover part of the configuration where we use a unified Mangle rules and apply it to an interface port where the radios are connected. I won't go into step-by-step configuration. Instead, the screenshot that I will show you has the column enabled where relevant specific settings required. Here's the configuration. First, you create a bridge port interface, and then bind the physical interface to the bridge interface. People would always ask me, why do I always use a bridge interface? Why not just use the physical interface? For one thing, with the bridge interface, you can set the IP on the bridge interface rather than the physical interface. Now, if you need to replace the physical interface, you don't affect the IP addresses. You don't affect all your rules. You're only changing the physical interface, but not the actual IP of the bridge interface. That's why I always use bridge rather than directly assigning an IP to a physical interface. Now, here is the Mangle rule. There's no really spatial about the Mangle rule, just as it is, standard Mangle rule. One of the trick is do not reference any input or output interface on each Mangle rule. That way, we can reuse the rule and apply it to all interface. Imagine this. If you have like rule number 11 and 12, if I put an interface in the input and output interface, that particular rule will only apply if the rule is coming in and out of that particular interface. Okay? So we are trying to avoid any reference of physical interface here. So you'll just create the Mangle rule with no reference at all, except the port and the destination or whatever parameters that you need. Now, according to the MikroTik, bandwidth control is based on dropping the packets where the queue size hits maximum limit. A lot of my clients are very confused about the queue size and how the bandwidth work with the MikroTik. Basically, the bandwidth is based on dropping the packets. So when you assign a queue limit, and when it hits the limit, it starts to drop the packets. For example, here at the queue type, we have the PCQ, ratio is 0, limit is 50, total limit is 400. What it means is that in every substream, I'm only limiting 50 kilobytes per substream. What does it mean? Look at my qualifier. I use destination address. If the destination address reaches 50 kilobytes, it will start to drop the packets. And that is how you control the bandwidth. In this case, we have 50 as the limit and 4,000. What you'll do is you divide them to find out the number of users. So with the 4,000 kilobytes divided by 50, approximately what? 30 users. So 30 users, that's your limit. Here is the Q3 and Q types. Okay. Site 1, I set the parent as the site 1's parent bridge, and then under that, I'm sure I could really, you know what? And under that, let's go live. Let me go live with one of the client. Go. Sorry. Slow internet here. Still not logging in. Here's a live. Here's a live stream, live Winbox in operation. Look at the site number 1. As you can see here, the parent is the Pasiano bridge. That is the bridge where the physical port is attached to. Now, from this site, from site number 1, all the way here. From site number 1 all the way, oh, where is it? So this is site number 1. If you will look at the queue type, internet's slow, so there you go. I have a queue type here, which I created only for that particular site. What happened is in each location, you must create its own queue type. So if you have 3 locations, then you create 3 queue types with the same thing, with the same configuration. The reason is you don't want to overload the main and the default, which you would normally use. So if I have, so let's, I'm very sorry. I'm just, the reason that you have to create a queue type, a separate queue type for each site, so that you don't overload one queue types only. What people would normally do is that they only use one queue, particular queue types and apply it to all. That will exhaust the queue limit. All right? Just imagine this. Suppose that I use a default with a 50 queue size and you have 3 different sites. You are exhausting all this for all 3 sites. Instead, we create another set of queue types and apply the queue types on that particular interface only. Like in this case, I have a different queue type here and a different queue type there. So each site has its own queue types. Okay? Now, look at the site number 1. On the site number 1, on the download, which is tied to the Pasiano Bridge, I set 25 megabit of allocated speed. And then there are 2 substream or 2 child substream, browsing stream and online gaming, and under that, another substream. Most of the time, I see configurations where the limit at for the child substream is equivalent to the max limit. Have you tried that? Well, the limit at is basically your CIR. To get the limit at, what you need to do is count the number of machines or computers that you have on your network divided by the bandwidth. So if you have 10 megabits of speed and you have 10 computers, each computer should have 1 megabit. So if you add them all up here, should be equivalent to your max limit. 500 multiplied by, what's that, 30 or 25 gives you 10 megabit. And then you add this, the max limit, that will be equivalent to your max limit on the parent. I'm very sorry, I cannot really see it from here. So if you will look at the gaming here, which I set 10 megabit, and then 10 megabit for 15 megabit for the browsing and streaming, that is a total of 25. Now I can adjust speed from here without affecting the others. Okay? And using the same Mangle rule. I didn't create a Mangle rule only for one specific site. Instead, I just use one Mangle rule here. Internet is really slow. So I have the whole Mangle rule here. No reference to any of the interface because we need to use the Mangle rule and apply it on our Q3. All right? If I want to increase this to, say, 7 Mbps, I'm only limiting the video streaming on that particular site and not on the rest of the site. So now you have full control of bandwidth management on each location without affecting other sites. And the only thing that you need to do is to create a bridge port to create a bridge port and tie it to your physical interface where radios are connected. Okay? Very simple. Now you have one Mangle rule unified, and you can reuse it to all of your remote sites. Do you have any questions? It's very simple, really. It will only take few minutes to do this. Do you have any questions? Yes. Uh-huh. No. Uh, that's not entirely correct. Well, the bridge mode, as compared to a physical interface only, bridge gives you more flexibility in terms of capabilities like filtering. Okay, here's an example. Here is the bridge. If I go to filter, I can filter the bridge, and you cannot do that on a physical port. Now, what you probably read from a forum is if you apply too much filter on the bridge, then yes, it will take up a lot of CPU processing. So using a bridge is not really that. Bridge is a software based, okay? It is not a hardware based. Instead, you create a software based interface and attach your physical interface to that. And from there, you can perform a lot of filtering rules. You can perform nothing rules, things like that. You can even filter the ARP, which you cannot do that with the physical interface. So it's different. Anyone else? Yes. So let's go back to the Q3. Here's the Q3. Yes, the whole network of the, because here you are controlling the interface of your core router. You are not the queuing and the bandwidth management is not based on the IP address. Now, if we go to the simple queue here, if I add a queue here, it will always ask you a target. You don't see any interface there. Instead, you have to supply it with the IP because simple queue is based on limiting the speed or bandwidth management based on the IP address or subnet. And I don't want that because I don't care about the IP of one network, one remote site. Instead, all I want is going out of this interface must be managed. So that is based on the per interface rather than an IP address. No, that will affect the whole network because on the Q3, I specifically says the parent is a bridge. So the whole network, the whole segment connected to that physical port will be affected. Anything else? Yes, you can do that as long as the uh, the interface is attached to a bridge and you control that bridge. So if you have like a PPPoE or EOIP and that's an interface and use that as your parent, then yes. So it's not an IP-based bandwidth managed control, but on a per interface. And I really don't care about the IP because one of the drawback of basing your bandwidth management based on a simple queue is that if one of your clients replace the radio with a different models, then the simple queue will no longer in effect unless you set it with the proper IP addresses from the old radios. But if you are going to base it on a per interface, it doesn't matter what kind of radio you use. right? So I don't really use simple queue. Very seldom I use simple queue. I don't, for the past 2 years, I've never used a simple queue because it's very limited for me. It's inaccurate. I mean, just my own opinion, and it creates a lot of latency, especially if there's thousands of IP addresses, and it's very hard to specifically uh, set one particular IP only to have that bandwidth management. So I always go for the per interface rather than on an IP. Anything else? So what you want is what? It's not the whole subnet. We're not talking here a subnet. We're talking here the whole interface. Whatever you connect to that interface will be affected by that. Now, if you want to control the bandwidth of a specific IP, I think you'll just have to use with with your Mangle rule, and then you just reference your source IP and destination IP. Yeah. Because what I've done here basically is limiting the interface, the whole interface. So whatever you put there, a cable, a wireless, a radio, your laptop, you will only get that much of speed, right? Okay, anyone else? Anyone else? No more questions? All right. Let me just close this. So that's it for me. I mean, it's not really that much really. Thank you.
Thank you very much. The next presentation by Dan Bogart. Dan. Okay. Go to see, find him.
Hello? What? Oh, another CCR? Oh, thank you. Now I got two CCR. Should be here presenting.